A sample of aspartame is hydrolyzed with aqueous acid. Draw the structures of 3 organic products of the complete acid hydrolysis of aspartame. So we know it's acid hydrolysis. So this means, as it's acid hydrolysis, any NH groups, so it could be NH3 or NH2 if it's an amine, for example, will always have an extra H, for example, like that, and the N will contain a plus, because this amino group will be protonated. And so if we have a look over here, it's hydrolyzed. So anything that can be hydrolyzed is always an amide or an ester, for example, just those two. So if we look up here, we know that it's going to form methanol, so we can draw one of those. This is where the bond will break with the ester hydrolysis. An H will join onto this O here, and an OH will join onto this carbon. So if we draw the methanol first, it's just simply going to be H3C bonded to an OH like that. Now to figure out the other 2 products, because there's 2 boxes here, the next one we have to hydrolyze is going to be this amide bond here. And so as you can see, the rest of this molecule, so if you get rid of that methanol there, this is a whole group here. So that's all you'd have to draw, like so. So if I draw it down, actually I'll draw it here so it's easy to see. So draw the benzene ring, like so, that coming off like that. And then it's just going to be HO. It's not a carboxylate. It would be a carboxylate if it was base hydrolysis, but it's acid hydrolysis. And so it's going to have an NH there, but it's going to be NH3 with a plus like that. If you're struggling to realise how many H's it needs in order to get a plus, the N will be bonded to 4 bonds in order to get a plus. So if this N had another carbon group coming off of it, it would be NH2 carbon-carbon plus, because it needs 4 bonds to have a plus there. And so that's the final, that's the second one, sorry. The final one is just going to be like so. So you've got a carboxylic acid group like that. And then it's going to be bonded to a carbon, bonded to an NH. I'll get onto it in a second. I'm just going to draw the rest of it really quickly. Like so. And then this NH, as I said up here, it needs 4 bonds to be positive, and every N will always be protonated. No matter if it's an amine or if it comes from an amide, it will always be protonated. So once again, NH3 plus, because it needs 4 bonds.